here. You can see that these rocks are all layered. And in fact, they're sedimentary rocks, probably, and they're altered. They have minerals in them that show a very long interaction with water. And what this all tells us when we get together with some additional information, here's some other layered rocks. You can see they're very finely layered. They're not curving. What happened is we drove the rover up onto a slope, and the camera looks like this as it turns. These layered rocks probably represent a time in Gusev Crater's history, again about 4 billion years ago, when there was water around, there was volcanic activity, we knew this from the lava flows, but that in places like this place that we call the home plate, that volcanic activity interacted with the water and it was very explosive. And in fact, our bum wheel, which is dragging along in a couple of places near where those layered rocks are, dug up this very, very bright soil. And when we went back and looked at that, we found out that it was about 90 to 94% silica. It's very similar chemically to the kinds of things you see around hot springs. And all of this points to a story that says that after Gusev Crater formed and water was still abundant and stable at the surface of Mars, volcanic activity was ongoing, that water interacted, caused some steam explosions, but then there were persistent areas where at least fumaroles and maybe even hot springs persisted for a while. Well, those of you that have read National Geographic over the past years have seen stories about Yellowstone Park, and you've seen stories about life that occurs in those hot springs. One of the ideas is that this is an ancient environment where life, if not here, perhaps in other locations on Mars, where such things may have been more persistent, more commonplace. In fact, you might have had a habitable environment. So we start to piece together this story with the Spirit rover that even though we landed on this sort of lava flow, which a lot of people would say was boring, although others would not, we certainly made it to a location where all of the objectives of the mission have been met. Now flash forward to the story that I told some of you at the beginning about Spirit being stuck for a while. We hope that again in the fall that it's going to come out of the hibernation, that we can extract it from this place that it's stuck, and we can continue this exploration. Because it turns out that where it's stuck is right here. Now I should give you a little background of what you're looking at. This is a high-rise camera view, much similar to the things that are flashing on the screen up here, taken from orbit, down looking at the surface of Mars. And the high-rise camera, you guys have how many megapixels in your camera?
12.
12 megapixels. Well, each pixel on the high-rise camera resolves a surface on Mars that's about the size of this piece of paper. So we can actually look at things about the size of this table, because it always takes more than one little spot to tell what something is. Look at things about this big and tell what they are on the surface. In fact, this image shows you the Spirit rover. That dot right there is the Spirit rover. This was taken back in, I think, 2006. Now, since that time, Spirit drove and we're stuck right over here now in the soft sediment. But if you look, this feature that I showed you that was layered called home plate along the Columbia Hills, there's a bunch of them. Okay, and these two down here are called Goddard and Von Braun. And they look like they're a little bit better preserved than some of these. And we really want to make it out of the sand trap down to here, because the silica deposits that we've seen in various locations around home plate may be preserved in better context down here. And maybe it's better able to tell us about, was it a fumaroil with just steam coming out, or was it really a hot spring? Those kinds of questions are very important when you're thinking about questions related to possible past life on Mars. So that's kind of what we hope to get to with the Spirit rover in the coming years. This shows you where we're stuck. Here's one of the wheels just at the top of it, this very soft sediment. We had a great view of where we were stuck, but unfortunately we haven't been able to get out yet. Now I'll move on and talk a little bit about the other.
A child has been found in the museum.
Anybody missing one?
Please go to the security.
Carry on. Now the other rover on the other side of the planet, because Mars Day is 24 hours and 40 minutes long, it's about 12 hours and 20 minutes out of sync. So when we were working both rovers early on, it was literally like doing operations on the east coast of the United States and then flying to India to do the next one all in one day and then flying back. So there was a real problem with sort of pseudo jet lag in terms of not knowing what time it was, and then throw in the mix that every day you shifted 40 minutes relative to an Earth day, and it really led to some sort of bad sleep habits, etc. Now what you see here in the background is an image of a place called Meridiani Planum, and I think some of you were here earlier when I said the top of this table makes this look, this makes the top of this table look like the Himalayas. It's a very, very flat surface. We were interested in going there because we had some data from another spacecraft in orbit around Mars that said something was interesting. So what you see here is a close-up view of a portion of this flat surface, and this was taken right up in this colored area that you see here in the top right corner called the inset. This is a very broad area. Each one of these craters that you see here is, on order of maybe 50 to 100 miles across. So this comes from a little piece up in here. And what you see is that the vast majority of this colored image is blue. Blue in this case means what I'm about to tell you wasn't there. Where the colors are, though, it was there. It turns out to be the mineral hematite. Hematite is something we've seen in very few locations on Mars, and nowhere have we seen it in such aerial abundance that we do here. So everywhere we see red, that's a lot of hematite. Yellows and greens are intermediate. Again, blue is none. Hematite is a mineral on the Earth. Some of you may have jewelry on that's made out of hematite. It's a semi-precious stone that's very, very often associated with water. It's an alteration product. Basically, it's an iron mineral that forms. Sometimes it's purely volcanic, but sometimes it forms in association with water. Because we didn't see any volcanic landforms here, the idea was that landing here, this hematite would allow us access to minerals whose origin related to past water on Mars. So that's why the Opportunity rover was sent here. Very different philosophy than the Spirit rover. The Spirit rover was sent somewhere based on what the surface looked like. We thought there was a lake there. Here we saw chemical evidence. Well, we landed right up here in a perfect hole-in-one in a little crater called Eagle Crater. This shows you some of the driving that we did. And here's this little crater, and there right in front of us, when we basically stood up after landing, was this light outcrop of material. And we called it Opportunity Ledge, and all of us lost track for a while about the scale of the rover and the scale of the outcrop. It turned out that the wheel of the rover is about that big. So this is actually something only that high. So for a long time people were calling this the Great Wall. It's actually the Great Curve. But what we saw here, now everything that you see in white, this is basically the same image that you see here, part of it. What you see in white are those outcrops. That's the Great Wall. What you see color-coded on top of that is the Mini-TESS instrument that looks at the thermal emission of the rocks around it and says something about composition. The Mini-TESS's interpretation of where the hematite is. Where there's red and yellows, there's hematite. Again, blue, no hematite. And what's interesting is if you look closely where the blue is, you see these marks. They look like basketball, like on a basketball. That's where the airbags from the rover hit. So what we learned was that everywhere the airbags touched, the hematite went away. So we're thinking, what is this? Is it dust? And it's gone? Or what's going on? Well, we took some microscopic imager views of the soil, and what we saw were these spherules. They were dubbed blueberries because in false color they looked blue. We did that because we wanted some way, a signature, to find out where the hematite was. These are hematite rich, and wherever we saw hematite in the Mini-TESS, we see these spherules, or blueberries. Where we didn't see them, it was just this basaltic sand. So everywhere the blueberries were, hematite. Where they're not, no hematite. Everywhere the airbags bounced, no hematite. Spherules were pushed down into the sand. So suddenly now we have our indicator of where the hematite's coming from. The other thing to look at is if you look very carefully, you'll see that some of these have a band kind of around their middle. That band, that equatorial band, and other features associated with these are very, very similar to, in fact, some would argue diagnostic of, things called concretions.